Okay, so the next thing that we want to talk about is very large and very small fractions. If the denominator of a fraction is fixed, such as x over 4, so if that denominator is a constant, the value of that fraction is determined by the value of the numerator. So what happens if that numerator keeps getting smaller and smaller and smaller? If that were the case, what happens if I let this get smaller? Let's say if I have 16 over 4 is 4, 8 over 4 is 2, 4 over 4 is 1, 2 over 4 is a half, 1 over 4 is 1/4. So as I let, what we want to say is we say that the value of the fraction x over 4, the value approaches 0. So the value approaches 0 as the limit, or as a limit, as the value of x gets closer and closer, to 0. So that's a concept that we talked about in pre-calc this year, is that limit. So the limit as x approaches 0. So we said if the numerator is 16, what if the numerator is 12? What if it is 8? What if it is 4? What if it is 1? What if it's a half? If it's a half, you're going to have 1/2 divided by 4, which means 1/2 times 1 over 4, and you get 1/8. So what happens as you calculate this fraction, this value, is going to approach 0. So it approaches 0 as x gets closer and closer to 0. Maybe the numerator is fixed. If the numerator is fixed, such as 4 over x, now what happens? So the value of the numerator, if that is fixed, the whole fraction's value depends on the denominator. Now remember, if I ask you to compare 4/10 to 4/100, which one is larger? Well, I would rather have 4 pieces out of a whole split into 10 than 4 pieces out of a whole split into 100. So take $1. If I split it into 10 increments, that's going to be 10 cents, and I get 4 of them, so I get 40 cents. If I take $1 and split it into 100 increments, I'm talking about a penny, and 4 of them is going to be 4 cents. So the smaller the denominator, or the larger the denominator gets, then your fraction is going to get smaller. So what we say the value of the fraction, if x is a positive number, it can't be 0. We don't want to talk about negatives. So if x is a positive number, as it approaches positive infinity, then the value of this fraction, so as I keep letting that fraction value get larger, as it approaches infinity, then what happens to the value of the fraction is it keeps getting smaller and smaller and smaller, and it approaches 0. So they're saying the limit as x approaches infinity, when x keeps getting larger, that fraction approaches 0. So that's one of the concepts that they were talking about in this particular lesson. The same thing, as x approaches 0, as it keeps getting smaller in this case, then x over 4 approaches 0. So those are two concepts dealing with really big and really small fractions. The next concept we want to talk about then is quadrantal angle. Okay, so the last thing we want to talk about is we want to talk about the signs of certain quadrants, what sine, cosine, tangent are going to have as far as the value is concerned. We already talked about that in the unit circle, and we said that remember cosine, which refers to x. Cosine is your x value. That's positive in the first and the fourth quadrant. I drew the cosine curve, and we can see that cosine is positive in the first and the fourth and negative in the second and third. Well, if you were looking at the x values, you were splitting it right here with the y-axis, and anything to the right is positive, anything to the left is negative. So first and fourth quadrants, as we look at our quadrants, 1, 2, 3, and 4. The first and the fourth quadrants will be positive. Now you talk about sine, and sine represents your y values, because we said that in our unit circle we were referring to our coordinate point in alphabetical order. Just look at, like we talk about the coordinate points x, y, cosine, sine. So sine refers to y, so y is positive in the first and second quadrant, but it is negative in the third and fourth. And when you look at the sine curve, you see that it's positive in the first and second, negative in the third and fourth. Now, something else that we have talked about is we could just remember the phrase starting in the first quadrant: all students take calculus. So what you're going to find out is that sine, cosine, tangent, all three trig functions are positive in the first quadrant. Students is just referring to s. Sine is the only one that's positive in the second quadrant. Tangent is the only one positive in the third quadrant, and cosine is the only one positive in the fourth quadrant. Now, something else that you could talk about is we know that tangent is going to be equal to sine over cosine. So if sine is positive in the first, if sine and cosine are both positive in the first, a positive divided by a positive is a positive. So tangent will be positive in the first quadrant. In the second quadrant, sine is positive, cosine is negative. If you take a positive divided by a negative, you end up with a negative. So tangent will be negative here. In the third quadrant, though, sine and cosine are both negative. A negative divided by a negative is a positive, and that's why tangent is positive in the third quadrant. Now, we know we could talk about the sine of 0 degrees is 0. At 90 degrees, sine has a value of 1. At 180 degrees, sine has a value back at 0 again. And then you're down here at 270. At 270 degrees, sine is negative 1. And at 360, it is 0 again. We looked at that with the unit circle, and we said with the unit circle, all you are doing is you are looking at these coordinate points right here. And remember, in a unit circle, the radius is 1. So this is the coordinate point 1, 0. So we talked about how you could find it by looking at the unit circle, or you could look at the curve. Cosine. Cosine, you are looking at the x values. If I just look at this graph right here, the smile, cosine at 0 degrees has a value of 1. At 90 degrees, it has a value of 0. The cosine of 180 degrees is negative 1. The cosine of 270 degrees is 0. And the cosine of 360 degrees is 1. So what about tangent? Well, let's look at the tangent of 0 degrees. The tangent of 0 degrees is sine divided by cosine. So as you look at it, you are going to get sine has a value of 0 divided by cosine, which has a value of 1. 0 divided by 1 is 0, so I get this point right here. If I look at 90 degrees, sine is 1, but cosine is 0. And 1 divided by 0 is undefined. You cannot divide by 0. So here at 90 degrees, it's going to be undefined, or I have that vertical asymptote. It's going to approach it but never cross it. Well, what happens at 180 degrees? At 180 degrees, you get 0 divided by negative 1. And 0 divided by negative 1 is 0 again. What happens at 270 degrees? You are going to have -1 divided by 0. And you're back to being undefined again here at 270 degrees. And then 360, you are going to have 0 divided by 1, which is 0. So if I look at the curve of it, now you have to start talking about quadrants. In the first quadrant, between 0 and 90 degrees, you have positive over positive. This is a positive value. What happens is the tangent curve is going to look something like this, where back here at -90 degrees, you're going to get that vertical asymptote again. So if I look at the second quadrant, if this dot is 180 degrees, remember, in the second quadrant between 90 and 180, you have a positive divided by a negative. That is a negative value. So your graph curves down like this. But then in that third quadrant, it goes back to positive. And then you're going to have the same thing repeat again. So your graph looks something like this for tangent. So you can figure out what the tangent value is just by taking sine divided by cosine for those particular values of 90, 180, 270, 360. So there are times like the tangent of 90 is undefined. As far as the sines go, we talked about that in the unit circle. You may be asked to find 3. Maybe they will ask you to find 3, the tangent of 180 degrees. If you want to, you could look at this graph. If you want to know what the tangent of 180 degrees is, you could say it's 3 times the sine of 180 divided by the cosine of 180 degrees. So the sine of 180 degrees is 0. The cosine of 180 degrees is -1. So you're going to get 3 times 0 over -1. 0 divided by -1 is 0. 3 times 0 is just going to give you an answer of 0. So you can calculate your particular expressions. Okay, so I have one last example. I got about 2.5 minutes, so I'm going to try to go through it quickly. When you get to a problem that looks like this, so this example here, if they ask you the sine of -135 degrees, so you're going to go down 135 degrees, which is going to put you into the third quadrant, and your reference angle is going to be 45 degrees. So you say, what is the sine of 45 degrees? That's radical 2 over 2. So we get radical 2 over 2. In the third quadrant, all students take calculus. Sine is negative, so that makes it negative radical 2 over 2. And then I want to continue on with the next part, the cosine of 180 degrees. So I think about the sine of 180 over the cosine of 180. So the sine of 180 is 0 over the this just says cosine of 180. Sorry. The cosine of 180 degrees is -1. So we're going to have plus 3 radical 2 times -1. So what that ends up with is negative radical 2 over 2 minus 3 radical 2. You want to get a common denominator. That common denominator is going to be 2, making this a 6. And when you group them together, you get -7 radical 2 over 2. So that's an application of all of these concepts dealing with sine, cosine, tangent, of certain angle measures, looking at the unit circle, and making some calculations. Now, you could, I know the calculator is going to be available there, but they're going to want you to put this in exact value. They may say draw the reference angles, or reference triangles, but you don't have to do that. Just use your hand, sine, cosine, tangent. If you need a refresher on that, let me know. All right, the video is going to end in about 30 seconds, so I'm going to go ahead and say we're good, and then maybe we will look at lesson set 30 next week. I'm not quite for sure what the plan is. That'll be your last week if you have everything done and passing. If not, we'll see you till the 20th, but I hope to be done with you May 8th. Have a good day.